Hey, welcome back to another lesson today about the atom and the structure of the atom. So we got some specific goals for today, and this is what they look like. Take a moment to read them. Okay, we got rid of some of that old school Jason Derulo. So if you look specifically what today's lesson will be about, one thing that I'd like you to learn would be to be able to use what we call isotope symbols. Sometimes those symbols help us communicate about the makeup of an atom, meaning the number of protons, neutrons, or electrons. And that information is sometimes useful for other ideas in science. So it's kind of a nice basic building block. The second thing we want to take a look at today is how atoms would be different than ions and how symbols would communicate whether or not something is either an atom or an ion. Specifically, we look at this idea of whether or not it has a net charge. So let's get right underway with the lesson. We'll get rid of my face here so we can have a little more room on or space on the screen and not be so easily distracted. There we go. Okay, so what we're going to be taking a look at is how we understand some symbols that represent what we call isotopes. So what you're going to have to recall is what isotopes are. If you look at the bottom of the screen here in this little table that's down below, you're going to notice lithium-6, lithium-7. Well, these are isotopes, atoms of the same element, different numbers of neutrons. Oxygen-15 and oxygen-16 are also a pair of isotopes, atoms of the same element, different numbers of neutrons. Let's get underway with some of the detail then. Okay, so one thing I'd like you to learn today is a kind of a new key term. That key term is something called an ion. And anytime that an atom has a charge, we would call it an ion. Well, one of the reasons it would have a charge would be related to protons have a charge, positive, and electrons have a charge, negative. Whenever those quantities of protons and electrons are not equal, we end up with something called a net charge. If those quantities were the same, that would be the amount, that would mean the amount of positive charge and the amount of negative charge would be the same. And then we would not have what we call an ion, we'd have what we call an atom. So specifically, here is the symbol for a very specific isotope. Notice it has a charge, so it carries a net charge. And this is the element lithium. So we could use a periodic table to identify that. Let me see if I can locate a copy of a periodic table to share with you here on the screen. There we go. I really like this version of the periodic table. It's nice and large. Numbers are very readable, so it'll be the one that we'll probably use for most of our work. Specifically, when we look at a periodic table for right now, the information we want to focus on is this idea right here called atomic number. If you remember from yesterday's lesson or previous lesson, atomic number simply reveals the number of protons. For example, hydrogen atomic number 1 has 1 proton, helium atomic number 2, 2 protons, lithium atomic number 3, 3 protons. So we look for what we call atomic number. So the periodic table is something you'll want to have handy for most of the recent work that we'll be doing. And we would access it like it's a tool to help us deal with our work. So I'm going to ask you to try to recall that you have a copy of it and always try to use it. Okay, so here we go. We have lithium, which we just said a moment ago, atomic number 3. That identifies this as the element lithium. No other element has 3 protons other than lithium. Well, this symbol here gives us a lot of information. What I'd like this lesson to focus on is how do we interpret what this symbol tells us about this particular atom of lithium. So specifically, the number up top is something we call mass number. Notice I have both a gray and a red color here, which actually means it's made up of 2 parts. If we go back and recall the definition for mass number, total number of protons plus neutrons. Protons kind of think about that as red, neutrons kind of thinking about that as gray. So our mass number for this lithium atom is 6. Atomic number, well, all lithium atoms, the number on the bottom here, 3, all lithium atoms have atomic number 3. This other number over here on the right is what we would call net charge, which means this is actually an ion now, not an atom. And an ion carries a charge, like it says, because the proton and electron counts are not equal. So we'll take a look at that in a moment. So net charge, if there is one, it will be up here on the top right corner. If there isn't one, then that's typically not written. So this information is kind of just left out, and there would be no number written there. Just the 6 and the 3 would be provided. So we transfer the symbol down into our little chart here that tells us this is what we're trying to translate to understand. What I'm going to use over here on the left are some symbols to identify quantities of the subatomic particles, the protons, the neutrons, and the electrons. So notice at the top it says mass number is 6. So we can begin to fill this chart in. Mass number is 6. Recall what that means: total number of protons and neutrons. So if we wanted to visualize, the nucleus of this atom would contain 3 protons and 3 neutrons. Remember, the nucleus is made up of protons and neutrons. So the mass number is 6. Well, in that nucleus, 3 of those particles would be these red spheres here, protons. So our definition of atomic number is the total number of protons in an atom. So 3 of the particles inside the nucleus would be protons. That actually means the other 3 are the gray particles, the neutrons. So the sum total, 3 plus 3, adds up to the mass number. Mass number is a sum total of protons in red, neutrons in gray. Electrons, well, that is going to relate to whether or not the particle is an ion or not. So if there is a net charge listed, or we know the number of electrons, we compare it to the number of protons. Here they've given us a net charge. So I'm saying that there must be 2 electrons, and here is my thought. Well, first of all, I know the net charge is +1. Let me activate a drawing tool here, and we'll kind of speak about this a little bit. So we know the number of particles is, the number of protons is 3. So that means there's a total of +3 for charge. Well, what we know is, we know the net charge here is +1. What that actually means is the number of particles that are positive charged have to outweigh the number of particles that are negative charged. What I mean by that is specifically, we would know there'd have to be 2 electrons. Well, here's why. Electrons have a negative charge, so we know that there's 2 minus particles. If you compare 3 plus and 2 minus, notice we get a difference of +1. So the net charge in here is +1, and we know that because the number of electrons is less than the number of protons. That's why it is carrying a plus charge and not a minus charge. If there were more electrons, then this net charge would be a minus amount. If they were equal in value, protons and electrons, then the net charge would carry a 0 or no amount. So net charge comes from some information. So we call lithium-6, at least this symbol of lithium-6, an ion because it carries a charge. Let's clear the chart and try this again with some new information. So here we have a particle, lithium-7. Notice there's no net charge listed for this guy. So there's no number listed up here. So let's begin to take apart what this means now. Well, we transfer the symbol down into our chart. Remember, the number up top is called the mass number. Remember what mass number means. It's the total number of red particles, protons, and gray particles, neutrons. Really, it's the composition of the nucleus. In this case, there are 7 total particles in the nucleus. Well, since it's still lithium, 3 of those particles have to be protons because no other particle of lithium could have anything other than 3 protons. So we know the atomic number is 3, right? Atomic number means the number of protons. Well, how did we know that there were going to be 4 neutrons? Well, the mass number is the total number of parts in the nucleus, protons plus neutrons. 3 plus 4 makes 7. Now notice there's no net charge here. So net charge, remember that relates to the total number of protons compared to electrons, because those are our two charged particles. So our protons and our electrons here have to be equal. That's what would make a net charge of 0. 3 electrons, right? So if we were going to kind of use the drawing tool here to show that, 3 minus 3 means 3 electrons, plus 3 means 3 protons, excuse me. Well, doesn't that add up to 0? So our net charge is 0. So now we don't have what's called an atom, excuse me, an ion. Now we have what's called an atom. So let's see if we can't do this with just a few more examples here. So take a peek at your periodic table, look the element oxygen up, and see if that provides some hints about what you might want to do next. Let's clear our drawing up here. So we know that we're dealing with oxygen. Here is the isotope of oxygen we're looking for. So this happens to be called oxygen 15. Notice the name always relates to the mass number. It's the total number of parts in the nucleus, just like lithium with the 7 meant lithium that has 7 parts in the nucleus. Lithium 6 meant lithium that has 6 parts in the nucleus. Well, oxygen 15 has 15 parts in its nucleus. Since it's oxygen, 1, 2, 3, 4, 5, 6, 7, 8 of them are protons, right? So the mass number in this case, remember that's always the number up top, total parts in the nucleus is 18. The atomic number, which really just means number of protons, is 8 because it's oxygen. No other atom would have 8. So all oxygen atoms have to have atomic number of 8. That's 8 protons. Well, the number of neutrons is the difference between the mass number and the atomic number. If there are 8 protons, that means there are 7 neutrons. So 8 plus 7 adds up to our mass number. Now look at our net charge. Now our net charge is minus 2. Well, let's use a little logic and some reasoning. Well, it's oxygen. We know it has 8 protons. So we know it has a total of plus 8. Look at this though, doesn't it say minus 2? So that means in order to get minus 2, there's going to have to be 2 more electrons, 2 more minus pieces than there are plus pieces. So I would compare that to minus 10. When I do that, I get a net charge of -2 revealed right here in the symbol. So -2 is what our net charge would be. Well, what causes it to be -2 is the number of electrons. There are 2 more electrons than there are protons. We get a net charge of 2. And now we call this an ion because it has a charge or it carries a charge. So if we counted our electrons here, we'd count up a total of 10. Hey, notice this, our electrons are smaller in size than our protons or our neutrons. In yesterday's lesson, we took a look at the idea that the mass of electrons almost doesn't count. So we don't count them in what we call mass number. So we're noticing the mass number does not include those. Okay, moving forward to our last example. If you wish, maybe it might be a good idea for you to pause the video for a moment and see if you could fill this in without a lot of assistance. Okay, let's see what well, it'd be difficult for you to fill it in without having the symbol. My apologies. So here you have the symbol. Now let's see if we can fill in. Maybe you might wish to pause to see if you could fill in the remaining parts of this chart now below. Okay, I hope you had some success. So what you'll do is you'll transfer the isotope symbol in. Recall the number on top is always the mass number, right? That's the total parts in the nucleus. Since there are 8 protons and 8 neutrons, our mass number is 16. Since it's oxygen, atomic number has to be 8, right? All oxygen atoms have atomic number of 8. It doesn't matter which isotope it is. Oxygen 15 and oxygen 16 are still 8 protons. The number of protons, again, atomic number is 8. Well, the number of neutrons, right? Protons and neutrons have to add up to the mass number. So the total value is 16, 8 plus 8. Notice now there is no net charge. No net charge means our protons and our electrons have to be the same. Well, if I have 8 protons, right, that means I have 8 pluses, and I have 8 electrons, 8 minuses, that would add up to a value of 0, net charge neutral, 0. So we just figured out that the number of electrons is equal because the net charge is 0. Now we call this an atom and not an ion, and that's the way that we interpret dealing with isotope or ion symbols. Let's try it in the format that I wish for you to do it, where we'll get rid of a lot of this visual information, but we'll use just information that pertains to the periodic table. So you would look at a periodic table to help you fill in this information. So let me give you a little bit of guidance about how to do the first two, and then maybe you should pause the video to try to fill in the last one, and I'll give you the feedback after you've done that. So here we're looking at some missing information. The idea is to be able to fill in that missing information from the context that you've been provided. So we know we have aluminum. Well, we were given some information about aluminum. Well, if we look at the symbol and the name, right, the name tells us which version of aluminum this is. So we know that this is the version of aluminum with a mass number of 27. Right, mass number is total number of protons plus neutrons. We also know whenever it's aluminum, its mass number has to be 13, because if we look on the periodic table and look up the atomic number for aluminum, we would find that to be 13. Recall what atomic number means. It means the number of protons. So now how would I get the number of neutrons? Well, if we recall what mass number means, mass number is the total number of protons plus neutrons. So if the mass number is 27 and 13 of them particles are protons, that means the other 14 have to be neutrons. Now we want to figure out the number of electrons. Well, the number of electrons is revealed sort of by the net charge. Look, it says +3. That means there's 3 more positives than there are negatives. So if we know there's 13 protons, which are our positives, there have to be 3 more positives than negatives, right? Our electrons are our negatives, and there will have to be 3 less of those. Comparing those gives us the value of +3, net charge of +3. So our net charge, +3, is revealed by having 10 electrons. So we would call this an ion. That's because it has a net charge. Okay, let's move forward to the next example. And in our next example, we'll clear our drawing here. We're going to use the hints that they've given us. So they've given us lots of good hints about how to fill in information. So what we do now is we use our periodic table to help support us. We would look up atomic number 16, because that's what protons actually mean. The number of protons is called atomic number. So the element that has atomic number 16 would be the element that you and I know as sulfur. So you'd have to look on your periodic table, find atomic number 16. You'd find out that's the element sulfur. And look, it says this has mass number of 33, so you want to specifically name it, sulfur 33. That'll allow you to write the symbols, S, right? Mass number goes on top. Let's change this to make it a skinny drawing tool, 33 on top, right? Mass number. What goes on the bottom? Atomic number, 16, so 1, 6. There we go, sulfur, 33. Looking now at the number of neutrons. Well, the mass number is total protons plus neutrons. Well, look at, we know it has 16 protons. We know the mass number is 33. So the number that I would have to add to 16 to make 33 would be 17, Or you could think about the inverse, almost like this is a subtraction problem here. 33 minus 16 creates 17 neutrons. Notice it says net charge 0, no charge. So that means the number of protons and electrons are equal. So that would be 16. And whenever those are equal, it's not what we call an ion, it is what we would call an atom. Be a good idea for you to pause the video to see if you can use the context that you have to fill in the missing information. Okay, let's fill it in together now. So hopefully you looked up and you saw atomic number 12. Well, there's only one element with atomic number 12. Let's make the drawing tool a little skinny again. That would be the element magnesium. Okay, so we spell out magnesium. We want to be able to name the isotope. Well, the isotope would be named on what mass number it has. So mass number is the total number of protons plus neutrons. That looks like the mass number here happens to be 37. So we're going to call this magnesium 37. We're going to give it the isotope symbols. Let's change the color so it doesn't run into our other. So Mg is the symbol for the element, right? 37 would be the mass number. On the bottom goes the atomic number, 12. All magnesium has atomic number 12. Remember, atomic number means the number of protons, so we can fill that in. Net charge, well, it would have a net charge if the proton and electron counts were not equal. Look at this, 12 protons, 12 electrons, net charge 0. This happens to be an atom and not an ion. So here we have what we would call an atom. And we could fill in the last bit of information. So let's change our color again so we're not running together. Let's maybe go to green now. So let's take a look at what they told us. Atomic number 17. So we go to our periodic table and we're going to look up the element with atomic number 17. So that's going to tell me this is the element chlorine. Again, we're not guessing, that's coming from the periodic table. The whole number 17 reveals the atomic number for chlorine. Remember what atomic number means. It means the number of protons, so you could fill in your number of protons. Remember, mass number is the sum total of protons plus neutrons. So 17 plus 19 reveals 36, right? That becomes chlorine. 36 is the specific isotope of chlorine we're looking at. We could add our symbols now. Cl, the number 36, over the number 17, right? Mass number over atomic number. Here we want to be careful now. Now this has a net charge because the number of protons, the positive parts are plus 17. The number of negative parts, electrons, minus 18. Look at that. Isn't there one more negative piece, one more electron than there are protons? So that means our net charge happens to be -1 in this case. And that means we now have an ion. So this reveals our isotope of chlorine with a net charge of -1. So I filled the chart in so that when you use this as notes, you can just go back and look at that and reveal that specific information. So let's just quickly review to give you a chance to kind of wrap your mind around this. Your follow-up assignment will be to fill in missing information in a chart of this nature. So where do we get mass number from? Well, we got to recall what mass number means. Total number of protons plus neutrons. 3 plus 3 made the 6 for the mass number. Where do we get atomic number from? Well, that comes from the periodic table, folks. Every lithium isotope, doesn't matter which isotope it is, will always have atomic number 3, which means 3 protons. How do we get net charge? Well, net charge, we compare the proton count to the electron count. If there's 2 electrons and 3 protons, that means the number minus pieces is less than plus pieces, or there's 1 more plus piece than there are minus pieces. Net charge is going to be positive. If you look down here for oxygen, there are 2 more minus pieces called electrons than there are plus pieces called protons. Net charge is minus in that case. If the protons and electrons are equal, net charge is 0. Whenever the net charge is 0, we're talking about atoms. Whenever there is a net charge, then we're talking about ions. Ions could be either positive charge or negative charge. So I hope that you found this information useful in today's lesson. And your follow-up assignment will be to relate what we just spoke about, and you can use these notes as kind of a guide and a tool. Be sure to have a periodic table handy as you deal with the review assignment for this particular lesson. So until the next time, bid you peace, take care.